In this video, we're going to learn how to convert from rectangular to polar coordinates. So say you're given a rectangular point, x, y, but you want to put it into polar, r theta. So in order to convert, I'm first going to draw a line out from the origin to the point. This will help us find the radius. And then I need to identify an angle to go with this as well. So if I were to drop a vertical line, I would have this bottom side of the right triangle be right side of the triangle be x, the opposite side be y, and the distance from the origin to the points will be our radius. So already I can see that the radius can just be found using Pythagorean theorem. So r squared is equal to x squared plus y squared. Or you can use the form r is equal to the square roots of x squared plus y squared. But how do you find that angle? Well, if I'm given x and y and not r, I don't want to use sine or cosine because that would involve the radius, which I technically wouldn't know yet. What I can do is say that tangent of theta is equal to y over x. So I can use that to help me find the angle. Or perhaps you might use a different form where theta is just equal to tangent inverse of y over x. But we have to keep in mind that tangent inverse only gives us angles in the first and fourth quadrants. So this is fine for the first quadrant. Theta can just equal tangent inverse of y over x. And even the fourth quadrant, if it's down here, that xy coordinate, then tangent inverse would give me a negative angle to put it out in that quadrant. So it's okay for the first and fourth quadrants to use that formula. But I need to keep in mind what I need to do in order to find the angles for the other quadrants as well. So let me think about that. So I put a point in the second quadrant and a point in the third quadrant and draw a line. So the radius will still be found the same no matter which direction you go in. You'll be okay. It's always going to be x squared plus y squared, and it's okay if it's negative because it's just going to be squared. But the angle is different. In order to find this angle from here to here, I actually am going to think of a point out in this direction where now over here you would have a negative x and a positive y. In the bottom right corner you would have a positive x and a negative y, which would mean that the tangent value is still the same. Whether you put a positive over a negative or a negative over a positive, that fraction should still be the same. So in order to find this value, I'm going to add pi to tangent inverse of y over x, because it will give me the negative angle, but adding pi will put it in the second quadrant for me. So for quadrant 2, I'll just add pi to whatever tangent inverse of y over x gives me. And for quadrant 3, something similar happens. If I think of an angle straight across in the other direction, same magnitude, it's a positive x and a positive y, but in the third quadrant it's a negative x and a negative y, which would still yield the same fraction. So again, I need to add pi to it, to the angle I get for tangent inverse of y over x. So the rule of thumb is if you're in quadrants 1 or 4, you don't need to add pi. If you're in quadrants 2 or 3, you need to add pi to get your answer. So now let's try this out. So first we have 2, negative 2 as our points. So 2, negative 2. Pretty easy to graph. And I'm even going to draw a line out so you can see where it goes and what everything's going to mean. So first I'm going to find that radius. So r is just equal to the square root of 2 squared plus negative 2 squared. So 4 plus 4, which is the square root of 8, which can be simplified to 2 square roots of 2. Now I want to find the angle. Now luckily, tangent inverse on its own already finds that angle. So for my theta, is just equal to tangent inverse of negative 2 over 2. Tangent inverse. Which gives me tangent inverse of negative 1, which is the angle pi over 4. Negative pi over 4. That gives me a value of negative 1 for tangent. So theta is just equal to negative pi over 4. So my coordinate would be 2 square roots of 2, comma, negative pi over 4. Try it out for another point. Here we have 0, 3, a y-intercept. Now I have to be careful for tangent theta of y over x. If x is 0, this is undefined. So I need to add a point up here that x cannot equal 0 if I want to use that formula. So now I have to think about this problem a little bit differently. I have to think about how much it rotates to get to that spot. Its radius is pretty obvious from the origin. It's just 3 away. So I can already tell that r is equal to 3. And if you want to use the formula, you'll get 3 squared plus 0 squared. So it's just 9, which will give you 3. But I can clearly count that straight up. But the angle is a 90-degree turn in the counterclockwise direction, which would be positive pi over 2. So in this case, I didn't need to use my formulas because it was on a pole. When it's on the poles, it makes your life a lot easier. So we just get 3 pi over 2. Now this next one's definitely not on a pole. So we go to negative 3.5, so negative 3.5, negative 1. And now I have to find that rotation to the third quadrant and what radius it is to get out there. So it's definitely more than 180 or more than pi. So I'm going to first find the radius, which will equal the square root of negative 3.5 squared plus negative 1 squared. So r is equal to the square root of negative 3.5 squared. Oops, forgot to put that in parentheses. Which is 12.25 plus 1, which 12.25 can be rewritten as a fraction, 49 over 4. Plus 1, so it gives me square root of 53 over 4. So r is equal to the square root of 53 all over 2. Which would be, if I had to put it into a decimal, about 3.64. So you can understand about how far away that is from the origin. And then the angle, I'm in the third quadrant, so tangent inverse is going to give me an angle of the first quadrant, so I just have to add pi to it. And again, it'll be y over x, so negative 1 over negative 3.5. Let me rewrite that down with a little more space so you can read it. So pi plus tangent inverse of negative 1 over negative 3.5, which that is not a value I know on the unit circle, so I'm going to use a calculator. So negative 1 divided by negative 3.5. This gives me 15. I am in degree mode, so I need to represent this in degrees. So 15.9 9.5. I'll do 945 degrees. So my point can either be represented as 3.64, comma 15.945 degrees, if I want to use degrees. Or I could use an exact radius. Or I can use radians. So if I do that same entry from before, but in radian mode, it is 0.278 radians. So either way to write your answer, any combination of these two would be correct. And that is how you convert from rectangular to polar coordinates.